Hey folks, how's it going? It's Mr. Murray coming to you with a video on solving rational equations. So in this video, I'm going to be walking you through what rational equations are and the process behind solving them. And what you're going to see through this video is that the process is in many ways similar to stuff we've seen before around rational expressions. And that's because, as its name suggests, a rational equation is just any equation, as its name suggests, that contains rational expressions. So in this example, we have the rational expression 2x plus 1 over 5x minus 2, and it's equal to the rational expression x minus 3 over 3x minus 10. Okay, and so what we're going to learn is we're going to learn how to essentially take this, break it down, and figure out what x is. Now, some of you might be thinking, Mr. Murray, why don't I use cross multiplication? I wouldn't rule it out. I mean, look, if you use cross multiplication at this juncture, in theory, it could work, right? So you could do 5x minus 2 times x minus 3 equals 2x plus 1 times 3x minus 10. And I don't disagree with you that this is valid. The question is, how would you even solve this? Well, you'd have to expand out each side. You'd have to get one side equal to 0, and then you'd have to use a method to solve from there, whether that be the quadratic formula or factoring. I'm going to propose a method in this video that's a lot easier, okay? And so what I'll do here is we'll break it down. We'll get to understand this method and what we need to know. And then there's going to be examples that I'll do, will do, and you'll do. And then I'll have some extra problems for you guys to try as well. Okay. So to get started, let's say we go back to the rational expression we just had. And I'm going to cut off the denominator, right? It's not there. Now imagine how easy it would be to solve this equation if I told you that 2x plus 1 was equal to x minus 3. Well, what you would figure out is that x is equal to negative 4 because you'd move over the x and you'd get x and you'd subtract the 1. Okay, but the problem is it's not that easy, right? Because we have that pesky denominator. So the first thing we need to think about is how we're going to get rid of the denominator. So the first thing we need to think about is how we're going to get rid of the denominator here, right? That's what we have to think about. We need this to go away. So what I'm going to propose to you is let's think about it like this. I need to multiply both sides by the same thing because that's something I can always do with an equation. But I'm going to need the denominator to cancel out. So, for example, if I was to multiply the right-hand side by 3x minus 10, this denominator would cancel. But then I would have to do the same thing on the left or the equation wouldn't be balanced. Unfortunately, this will not cancel out with 5x minus 2. So what do I need to cancel out with 5x minus 2? I'm going to need 5x minus 2, right? So the 5x minus 2 will cancel with the 5x minus 2. And I'll just make sure I put a 5x minus 2 over here. And the 3x minus 10 will cancel with the 3x minus 10. But what I've essentially done here is I've used the greatest common factor. Because if you look at the denominator, well, look, 5x minus 2 times 3x minus 10 is just the greatest common factor. And when you multiply both sides by the greatest common factor, you're ensured that the denominators will cancel. And remember, as long as you multiply the same side of the equation by both things, by the same thing, everything will stay balanced. So what about this example here? I wonder how we could use that here. So I start to look at 2x minus 6, and I see, well, this is equal to 2 times x minus 3. And I think, perfect. I'll multiply this times x minus 3, and I'll multiply this times x minus 3. because then this and this will cancel, and this will cancel. So I'll have x is equal to, because this is just x now, 6 over 2, which is 3. And I'm good, right? Well, not quite, because here's the problem. What happens when you put 3 in this denominator? Doesn't work. So as it turns out, they're back. Extraneous solution. Dun dun dun. Right? Remember when we saw these with radical equations? We'd get a solution, we'd plug it in, and it wouldn't actually work. Same thing here. So what this is going to tell us is we should probably also think about what numbers cannot be plugged in, right? Even though it seems like we could be able to plug them in, what numbers will give us 0 denominators? Because those are things that we cannot plug into these equations, okay? And we probably want to think about that earlier on in the problem solving process, because once we actually cancel the denominators, we might forget about them later on down the line. Okay, so this is the problem solving process here. When we solve rational equations, 1, we need to find the excluded values. That's going to be important because we want to know if we get a solution, can that solution actually even be plugged into the equation? And if it's an excluded value, the answer is no. We're going to do this first because, remember, once the denominators are all gone and kind of messed around with, we might not remember what those excluded values are, or they might be difficult to find, and they're very important. Next, we're going to factor everything we can, especially the denominators. Okay, and I say that because once everything is broken down, we want to find the least common denominator and multiply through every single term in the equation by that least common denominator. And what that's going to do is it's going to make sure every single denominator gets canceled out. Now, sometimes it is going to involve doing things to the numerator because things won't cancel out perfectly, and that's something you'll have to think about. Remember, you're simply distributing here. You're just multiplying by the numerator only. You're not multiplying by numerator and denominator. That's something that's a little bit different. That's rewriting to make it equivalent. It's not quite the same thing. Then, once you've done step 4, all of the denominators should be canceled, leaving you with just an equation that is only based on the numerators, which will then allow you to get the variable alone. That will get you your x equals or v equals or u equals or whatever the letter is. Once you have that, you then need to go and check that it's not an excluded solution or an excluded value from step 1. So for example, once we got the 3, we needed to make sure that it wasn't in the list of excluded values. In this case, it was. So if it isn't in the excluded values, that's not a solution. There could be more than one solution. But what I'm saying is, if any solution is an excluded value, you have to eliminate it because it's extraneous. And then lastly, you really should check your work by plugging in and ensuring that both sides of the equation are true. All right, folks, so let's look at an example of this in action. So I have 3x plus 7 over x minus 5 equals 5x plus 17 over 2x minus 10. So first, I want to find the excluded values. The excluded values here are 5, because 5 will make this 0, and 5 will also make the second one 0. So first, I know that x is not equal to 5. That step's done. Now we're going to factor everything we can, especially the denominators. The only thing that's factorable here is the denominator on the right hand side of the equation. So we'll set that up, factor out the 2. Okay. Step 3, find the least common denominator of all the expressions. So here, the least common denominator is x minus 5, because that's the smallest thing that, in a sense, that with the smallest degree that I can multiply that's a factor of the left and the right denominator. Okay, now I'm going to do step 4, multiply everything by the LCD. So I'm going to come in, I'm going to multiply this by x minus 5, and on the right, I'm going to multiply by x minus 5, and that will clear this, and this, the 2 will remain. Okay, see, that's canceled. Now we're going to get the variable alone, because all that's left is 3x. So see how magnificent this is? Once the denominators are cleared, this is essentially all that's left. Now multiply by 2. And I'll solve from there. So I'll subtract 14, and I'll subtract 5x. I get x equals 3. I check, is it an excluded solution? No. So the final answer is x equals 3. Let's check our work. So I get 6 plus 7 is, 9 plus 7 rather is 16. 3 minus 5 is negative 2. 15 plus 17 is 32. 6 minus 10 is negative 4. 16 over negative 2 is negative 8. 32 over negative 4 is negative 8. Negative 8 equals negative 8. All right. Wow, what happens when we have 3 things? Well, we have to think about this. Let's construct our least common denominator. So remember, the least common denominator has to, at a minimum, well, ideally, it should cancel every single denominator. In the last example, I didn't really cancel the 2, but in this case, because there's 3 things, we probably want to cancel everything we can. So what I'm going to do is let's construct it. What are we going to need? What ingredients are we going to need to make sure everything cancels? So we're going to need an x minus 7. That will take care of this and this. And then we're going to need a 2 because it will take care of this. So that's what I'm going to come through and multiply by. So first, everything is factored, right? Excluded values, let's get those real quick. The excluded value is 7. All right, let's go for it. So I'm going to write this. So we've got 2x minus 9. So here's what our equation looks like factored, because essentially there's no real change. So you could say this is simplified in that regard. And I'm going to take the left-hand side, and I'm going to multiply it by 2 times x minus 7. And then I'm going to do the same on the right, because as long as you do the same thing to the left and the right of an equation, you keep it balanced. It doesn't really matter what x minus 7 is, because we're multiplying by that number on the left and the right. So here we do need to do a distribution. I'll talk about that in a second. Here, the x minus 7 will cancel, and the 2 will go in. So that becomes a 10. Okay, over here, it's going to be a little tricky. So first, let's do the 2x minus 7 here with the first piece. So if I did it there, the x minus 7s are going to cancel, and only the 2 will go through. So it will be 4x minus 18. On the second one, the 2's will cancel, and it will be the x minus 7 that remains, plus x squared minus 7x. Wow, okay. So let's bring this together. I think I'm going to make the right-hand side equal to 0. So I'm going to subtract the 10, and I'm going to combine the 4 and the negative 7. Something like that. Okay, and now I need to solve it. So let's solve it. So I've got x minus 7, x plus 4. Because negative 7 times 4 is negative 28. Negative 7 plus 4 is negative 3. And so if this is equal to 0, either x equals 7 or x equals negative 4. But we need to toss the 7 because it's extraneous. So the final solution is x equals negative 4. And let's check that. So first of all, negative 4 over 2 is negative 2. Here, this is negative 8, negative 17 over negative 11. And this is 5 over negative 11. Once you clean it up, what you're going to notice is that negative 17 over negative 11, right, is equal to positive 17 over positive 11. And then this is equal to negative 22 over 11. And 17 over 11 minus 22 over 11 equals negative 5 over 11. All right, here's another one. Let's take a look at this. So here we have our equation. First, we factor everything. Well, we find our extraneous values, right? So extraneous values. X cannot be negative 3, and it cannot be negative 6, because those would make our denominator 0. Okay, now we factor everything, which we basically have done. Now we need to find the least common denominator, and that is x plus 3 times x plus 6. Okay, and again, you're going to think about your strategy here. All your denominators need to go away. Now your numerators might be affected, but in the end, all of your denominators should be gone, and you need to be doing the same thing on both sides of the equation. Okay, so I'll distribute here, 8x plus 48, and I'll distribute here, x squared plus 4x plus 3. And now I'll combine like terms. All right. And now I'm going to need to factor this. So this is going to be, let's see. This comes back down to the factoring stuff. X minus 9, x plus 5. So I get 9 and I get negative 5. Now, neither of these are excluded, so I can keep them in. They're not extraneous. Let's check the work. So I've got 8 over 12 equals 10 over 15. 2/3, 2/3. Okay. 8 over negative 2 equals negative 4 over 1. Let's see, that's negative 4. That's negative 4. Yep. Okay, so these both check out. So 9 and negative 5 are the solutions. All right, folks. Now here's the one with 3. Let's take a look at this. So what do I need to do first, folks? I need to find what? The extraneous values. So the extraneous values here are only one, and that is 0. Now I need to factor, which is done. So I now need to find the what? The LCD. So the least common denominator is going to be, well, we need to first look at the numbers. What's going to cancel the numbers? That'll be 12. 12 is the least common denominator of 6, 4, and 12. And then what's the least common denominator of the x's? That'll be x. So if I multiply everything by 12x, it will ensure the numbers and the letters cancel in the denominator, right? Because the goal is to eliminate all denominators. All right, so here we go. 12x, 12x, 12x. So here, everything cancels. Here, the x's cancel. And the 4 and the 12, we end up with a 3 times a 9. Here, the denominator cancels, and we end up with just 10x. And here we get negative 13. So let's try to solve it. We move the 10 over, the 13 over and the 10x over, and we get 40 equals 10x. So x equals 4. It's not excluded, so that's a good sign. Let's check our work. Okay, 9/16 minus 5/6 equals negative 13/48. So that would be 27/48 minus 40 48ths equals negative 13 48ths. Perfecto. Okay, so same idea, but a little bit more complicated. All right, last one for us to try, and then I will move on for ones for you to do as well. So here I go. I've got 3 over x plus 1 plus 2/7 equals 2. So the first thing I'm going to identify is the excluded values. Okay, it's not negative 1. X cannot be negative 1. Now I'm going to factor, which is done, and now I will find the least common denominator. Okay, so think about the least common denominator. What would I have to multiply through by so that I could eliminate every single denominator and not multiply by too much? It would have to be 7 to get rid of the 7 there, and then x plus 1. So I'll come through and do that. 7x plus 1, 7x plus 1, 7x plus 1. Okay, so here the x plus 1s cancel and the 7 distributes. Here the 7 cancels and the x plus 1 distributes. So we have 2x plus 2. And here we get 14 times x plus 1, which is 14x plus 14. All right, let's try to solve for x. So I will... Let's see. How about I combine the 21 and the 2, and I move the x over, and then maybe I subtract, and then I will divide. So x is equal to 9/12 or 3/4. Okay, so let's see. 3 over 1.75 plus 2/7. All right, let's see what we get here. So if I do, I'm actually going to do this on my calculator. I'm going to do 3 over 1.75 plus 2 over 7, and my calculator will tell me 2. Folks, if you don't believe me, take a look for yourself. Ready? So, 3 divided by 1.75 plus 2 over 7 equals 2. Okay. Your turn, folks. So, remember the process. 1, you're going to find excluded values. 2, and if you need to, I recommend factor. Factor like crazy. And go back and add to the excluded values if needed. Find the greatest common factor, or rather the least common denominator, and multiply through everything by that. Once the denominators are eliminated, find the numerators. Okay, folks? So this is one for you to try. Please go ahead, pause the video, try to solve this one, and then when you're ready, unpause, and you can see what I got. Okay, so I think this is one where we probably want to be factoring first. So this one is equal to actually x minus 7 and x minus 3. All right. So as it turns out, what I'm going to multiply both sides by is x minus 7 and x minus 3. Okay, because I need to multiply the same thing on both sides. And when I do it on the left, the denominator goes away. And when I distribute on the right, in the first case, the x minus 7's cancel. And I get 6 times x minus 3. And in the second case, the x minus 3's cancel. And I get 5 times x minus 7, right? Because that's the only piece of these left, right? You can see that it hasn't canceled with the denominator. So I'll simplify that up. Okay. Let's combine some like terms. I actually kind of start moving stuff over. So x squared, I need to move over 11x. And then I need to move over the 35 and the 18. Right? So I've got that negative 29. I'm going to add the 35 and the 18 to it. And what I'll end up with is... Okay, now, just remember, and I got a little bit ahead of myself, x cannot be 7 or 3. So we're going to have to keep that in mind. So here we get x minus 3 times x minus 8 is 0, because that's how you factor x squared minus 11x plus 24. So x equals 3, or x equals 8. 3 is extraneous, so 8 is the only possible solution. If I plug that in, I get 64 minus 29, so this would become 35. And here, 8 plugging in is easy, because it's just 1 times 5. Just plugging it into the factors. Okay, here I'd have 6, because this is 1. And here I would have 5 over 5, which is 1. So 35 over 5 is 7. 7 equals 6 plus 1. Okay, guys, final you try, very similar to the last one. I need you to please pause the video, solve this rational equation, then when you're ready, unpause, and you can see what I got. Okay, similar idea. Let's start with a breakdown of everything. So this is x minus 2, x minus 1. This is 3 times x minus 1. So here's what we need for our LCD. We need 3. We need an x minus 1. And we need an x minus 2. That'll ensure everything gets canceled. So when I distribute it here, the x minus 1 and x minus 2 cancel. And all that gets distributed is the 3. And you get a 15 because it's 3 times 5. Here the x minus 2 cancels. And you're left with, it shouldn't be an equals. All you're left with is 3 times x minus 1 times 1. And then here, the 3 times x minus 1 cancels, and you have x squared plus 4x minus 12, because the x minus 2 is left to get distributed. Okay? Alright, so, keeping in mind the fact that we have two values, 2 and 1, that cannot be plugged in, let's go ahead and try to solve. So I've got 15 minus 3x minus 3 equals x squared. And actually, this needs to be a plus 3 because I'm distributing a negative to a negative. Okay. And now let's start to move some stuff over. We'll move over the negative 15, etc. So I'll get 0 equals, so this will be negative 27. This will be 7x. And actually, I need to take away 3 more. So this will actually be, take away 15 and a 3. So this will actually be 30. So x squared plus 7x plus 30. And I can tell by looking at it, right? So you can see the pattern. These often break down into pretty straightforward factoring problems. X plus 10, x minus 3. So that leaves me with, as solutions, 3 and negative 10. Let's see if any of those are extraneous. They are not, so they're both candidates. If I plug in 3, I get 5 over 1 times 2. Because that's 1, that's 2. Minus, okay, remember, we're plugging in 3. 1 over 1 equals 9 over 6. Okay? And we could verify whether this one works or not. This is 2.5 minus 1 equals 1.5. Okay, we could do the similar thing with the other. So if you're able to find this video to be helpful, please go ahead and continue on with the MyHRW assignment on solving equations. Best of luck. Don't forget to love math. And remember, you can do it.